Okay, hello F5 students. Today we are going to learn about coordinates and transformation. Okay, Miss Foni will share you the screen and will explain further what you are going to do and what you have to do today. Remember to submit. Remember to submit your work, your HBL today to your homeroom. Okay, to your homeroom, and your homeroom will then forward it to your subject teacher. Your subject teacher will have it checked and will have it sent back to you, okay? So make sure you submit today. I will appreciate if you can submit your homeroom today before 3 p.m. All right, before 3 p.m. today. Okay, I will start the explanation for coordinates and transformation. If you still have any further questions after watching my video, you can contact your subject teacher for further explanation. Okay. All right. Oops. Okay, what does the word coordinate mean? To coordinate means to do something in a set order. To coordinate, so coordinates are a way of ordering things exactly. Okay, with the person who's next to you, maybe your parents or your siblings, you can tell where you have seen or used coordinates before. Right, usually coordinate is used in reading map, okay, or direction like this, another map, okay, and something like that. Okay, there's a verb keyword which is important in coordinate. It's first, it's quadrant and coordinates. What is quadrant? Any quarter of a plane divided by an x and y axis are all quadrants. Okay, example, look at this. A quarter circle. Okay, a quarter circle is one quadrant. So in coordinates, this part is called quadrant 1. This is 2, quadrant 3, and quadrant 4. In quadrant 1, okay, mostly the coordinate that you put here will be all in positive number. They will give you all positive number. Okay, for example, 1.5. Okay, however, over here, okay, the x-axis will be negative number. However, the y-axis is positive. In quadrant 3, the x, both the x-axis and the y-axis, both the x and the y-axis are in negative. In quadrant 4, the y-axis is in negative, however, the x-axis is positive. Okay, so what is coordinate? Coordinate is usually used to show a position on a coordinate plane or map. Show as a pair of letter or numbers. Sometimes it's also written down in letters. But in this lesson, we will learn more the coordinate that's written down in numbers. The first coordinate must be the horizontal position which determines the x-axis. However, the second coordinate is the vertical position which is the y-axis. Let's see. If it's written down 4.2, it means 4 in the horizontal and 2 in the vertical. X is for horizontal, Y is for vertical. Let's see over here. Let's see A. A is in this position. So how do we read A? It's from X first, then Y. So how do we write A? Okay, we usually write coordinate from X first, then Y. Okay, so A, what is the coordinate of A? Okay, you can see on X, A here is pointed at the position of 2. All right. However, on Y, this is Y, this is X. On Y, okay, A is on the position of 1. So the coordinate of A is 2.1. The coordinate of A is 2.1. Okay. Next. Okay, how about B? Look at B. Okay, if I draw a line, you can see B is in this position. On X, it is, oops, Okay, on X, it is pointing at the position of 4. On Y, it is pointed at the position of 1. Okay, therefore, B, the coordinates of B is 4.1. Okay, that's how you read B. Right, let's see next. C, look at C. First, remember to write coordinates. You write first X first, then Y. Okay, for C, you can see over here, as you can see, okay. For X is showing -2 and Y is showing 1. That's why the coordinate of C is -2, 1. Okay? All right. Let's see. How about D? On X, D is -3. Y, it is 4. So the coordinate of D is -3, 4. E is 1.2. F is 3.3. G is -1.3. H is here in the middle. Okay, it is on 0x, 0y. So H is on the coordinate of 0.0. Oops, oopsie. Okay, I is on the position of, on X it is -4, on Y it is -3. So the coordinate of I is -4.3. J is on 3.2. Okay. Oops. Right, let me erase this. Okay, now let's plot. It's time to do plotting coordinate. Okay, it said plot A at 4.5. 4 here, remember, is the X. 5 here is the Y. Okay, where will we draw A? Okay, so we'll see. On the X, it is 4. On Y, it is 5. Okay, probably over here, 5, right? So 4.5 is over here maybe. Yeah, A. Okay, where to draw B? B is -2.3. Remember, -2 is X, or -2. 3 is Y. So B is over here. Okay, C is on -5.6. Okay. Right, maybe over here is -5. Okay, maybe here, -6. Okay, so C will show over here, down here, -6 is over here. So maybe C is on this part, -5, -6. D is -4, 3. So -4 on X, 3 on Y. So D over here, right? Okay, next. Right, there's a question. Copy the grid on the left, then plot the points. Okay, okay, all right. So we are going to plot 3.0, -1.3, -3.1. Let's see. 3.0, x3, y0. x3, the y is 0. So A is here. B is -1, 3. -1 is the y. 3 is the, -1 is the x. 3 is the y. So B is here. C is -3, 1. -3 is the x. 1 is the y. Over here. Okay. The question is, the next question, plot a fourth point which is D, okay, so that you can make a rectangle and write down the coordinates. Okay, so what do you think? Where can I draw the plot D, the fourth point? Okay, maybe we can connect first. We can connect the dot, the point that we already plot. Okay. Okay, so according to you, if I would like to make a rectangle, where can I draw the point? Any idea? Okay, so you see this plot is related here. It is two diagonal lines in between. Right, so for sure, to make a rectangle, I also need to have two diagonal lines in between. Okay, so therefore, B, I should plot B on this side. This side. Okay. Right. If I connect them, we will have a rectangle. Okay. So what is the coordinate of B? What is the coordinate of B? Remember X then Y. So the coordinate of B is 1 point negative 2. Right? That's how you solve questions about coordinates. Okay. Next. Oops, sorry. Okay, refraction. So now we're going to refraction. What is refraction? Refraction is a transformation that acts like a mirror. It swaps or pairs of points that are on exactly opposite sides on the line of refraction. So there are four characteristics of refraction. First, when you do refraction, the shape must be the same. So if this is a triangle, it should reflect it into a triangle, just as if you are standing in front of your mirror. Okay. Um, the shape must be the same, and then the size must be the same. So if this is the size of your triangle, the refracted object will have the same size. It could not be bigger or smaller. Okay, that's two. The third is that the refracted object must have the same distance with the to the mirror line with the refracted object. So for example, this one, this point, this point, it is 1 unit from the mirror line. So this point should be refracted also 1 unit from the mirror line. Okay, the distance must be the same. The same here. This point is 1 unit from the mirror line. So it should also be refracted 1 unit from the mirror line. However, the third point, this one, it is 1, 2, 3. 3 units from the mirror line. So it's also being refracted 3 units from the mirror line. 1, 2, 3. So the distance must be the same. That's the third. The fourth, when we do refraction, so the refracted objects usually facing on the opposite direction. On the opposite direction from the original shape. Okay, no matter what kind of mirror line it is. This is vertical mirror line. In horizontal mirror line, the same characteristic applies. In this diagonal mirror line, it's also the same. So you can see. You imagine, if you fold this line, these two figures will meet each other. So this point is like half box away from the mirror line. So it's also half box away. The refracted object also half box away. So the distance must be consistently the same. That's refraction. Go on. Translation. A translation doesn't change any object shape. So the shape does not change, the size does not change, and the direction even do not change. Okay, it does not change the shape, the size, and the orientation. The direction it is facing will not change. All right, will be the same. So this quadrilateral has been translated 1 space to the left and 3 up. What does it mean, Miss? So this is the original object. Okay, this point has been translated here. It's been moved up here. So how did it being moved up? It being moved up one box to the left, okay, and then three boxes up. One, two, three. That's why it is said over here, the object has been translated one space to the left and three up. Okay, notice that the new image is the same shape, the same size, and has not turned or flipped. It's all the same. Okay. Okay, so that's translation. Okay, let's see these questions. I've explained three things just now: coordinate, refraction, and translation. Question 1. There are 3 points, A, B, and C, are marked on the grid here in this picture. What are the coordinates of these 3 points? Try to think. What do you think is the answer? Remember, to read coordinates, you read x first, then y. So, for the coordinate of x, for A, it is pointed at 2, y, it is 6. So, A is at 2.6. However, B is at 1.5 and C is at 4.2. Very good. Okay. If A, B, and C are three vertices of a rectangle, what are the coordinates of the fourth? What could be the fourth coordinate B? Okay, so what we can do is we connect this. Line. We connect the line, the coordinates. Okay. All right. Pay attention. B is connected to C. B and D is one diagonal line distance. So what if they? B should and C should be also one diagonal line in distance over here to make a rectangle. Therefore, D should be plotted over here. Where is this? Where is D? What is the fourth vertex? D is 5.3. Okay. Number 2. Draw a reflection of each shape in the mirror line. So let's see. This is a diagonal mirror line. How do we draw the reflection? Remember, the distance of the point must be the same. So look at this point. Okay, look at this point. Right? This is here. From the mirror line, it is here. Look at it. Here. Over here. From this mirror line, it takes one diagonal box and half. So that's why the reflection must also be half plus one diagonal box. So it should be reflected here, this part, this one. Okay. However, this point is on the mirror line, so it will be reflected the same. Okay. This one, let's see this one. This one is also from the mirror line, it is also one diagonal line and a half box. So also we reflected one and a half box over there. Here. Okay. So the reflected object is can be drawn here. 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 Okay. So this is the reflected object. This is so you can see very All right. So this is how it looks when it is reflected on this mirror line. Right? Continue. The same goes here. Look at this point. How far is it from the mirror line? Look at this. This is the mirror line. Okay, so from here to the mirror line, it is one diagonal line and a half. So it's also reflected 1.5 diagonal line here. Okay, so it will be reflected over here, this point. However, the rest is on the mirror line, so it will be the same. So the point will be reflected on the mirror line as well. So what would be the reflection looks like? Okay, from this point is connected here. This one is connected here. Okay, I'll use this one. Okay, so this is the reflection. All right, do you understand? If you have any question, feel free to ask your teacher. Okay. All right, next. Okay, draw the new position of the rectangle after it has been translated 4 squares to the right and 2 squares down. So this is the figure. To the right, it means on this side. Down means going down. Okay, there going left, going up. Okay, so the instruction over here said draw it 4 squares to the right. So let's see. If I would like to translate this point 4 squares to the right, 1, 2, 3, 4 squares to the right, but then I haven't done. It said and 2 squares down, so I translated 2 squares down. 1, 2. So this point is now being translated over here. My rectangle is 3 times 2 shape. So I will draw my rectangle 3 times 2 shape. Okay. So this rectangle is now being translated here. 4 squares to the right, 2 squares down. Okay, this is how you do the translation. Or usually, if it's being translated to the right side, you can say plus 4. Okay, translation 4 squared to the right is the same with plus 4 horizontally. Okay, going to the right is plus, going to the left is minus. All right, and 2 squares down. Going down is minus in y-axis. Going up is plus. So this translated 4 squares to the right and 2 squares down is the same with plus 4 horizontally minus 2 vertically. Okay. It has the same, it will give the same output. Okay, let's see question number 5. Describe the translation that moves square A to B. Okay, let's see how do we move A to B. Look at it. From here, we see this point, right, being translated to this point. Okay, how? See, it's going up 1, only 1. Okay, and then it's going to the left. 1, 2, 3 squares. It's 3 squares to the left and 1 square up. So you can describe it as 3 squares to the left and 1 square up. Okay, or you also can answer if it is to the left horizontally, it is negative, minus. So you can say minus 3 horizontally and it's going up. Up means plus. Plus 1 vertically. Okay, both answers are correct. Okay, you can either answer 3 squares to the left and 1 square up, or negative 3 horizontally plus 1 vertically. Okay, that's about refraction and translation. Here, this is what you're going to do today, your task today. Right, then loading. Okay. Okay, this is what you have to do today. Refracting triangles. Okay, you can download this from EPOS. All right, this is the original shape. Okay, you draw the refraction here on this side. So I'll give and I'll try to explain one for you. Okay, you see, look at this point. Okay, it is half diagonal line away from the mirror line. So it's refracted half diagonal line away over here, right? Okay, and then pay attention again. This point, okay, this point, it is also half diagonal line away. So it's also being refracted half diagonal line away. So that point will be reflected here. And let's see this point. It is from here, from this mirror line. Okay. It is two diagonal line away. So when you reflect this, also two diagonal line away. Okay. So it's being reflected here. Right? So now we draw a line to connect them. So this is the refraction. Okay, I will erase. So you can see here. Oh, all right, like that. Okay, so you draw the refraction like this, right? For all the questions. Okay, next. Okay, next. Look at your book, page 118. You're going to do this. Let's investigate. First, you plot 2.1 and 4.3 on the grid. Okay, and then you find two more points on the grid that makes it a square. Okay, you plot it. All right, and then you write down what is the coordinate of that 2 point. Okay, there is more than one solution. Let me see how many you can find. Remember, you have to submit this also to your teacher. Okay, next, question number 1. Okay, for each of these questions, try to visualize where the refraction would be first, then use a mirror line or tracing paper to check. What are the coordinates of the isosceles triangle? This one. when it is refracted in the mirror line. Okay, so you don't have to draw this. All right, you can do the refraction. You can draw the refractive object on your reference book. Okay, just simply answer the coordinates in the answer book. So in question A, B, and C, you write down the three coordinates. So this is three-sided, right? So there will be three coordinates. B, there will be 1 to 4 coordinates, and then for C, okay, and then for C, 1, 2, 3, 4, 5, 6, there are 6 coordinates. You just need to write down the coordinates. Okay, for example, question A. So for question A, the refracted object is here. All right. So this is the refracted object. So you have to write down what's the coordinate of this, and this. Okay. So the three coordinates you write down. That's for question number 1. Next, number 2. Okay. In question number 2, all right. So okay, in question number 2, you use translation to move the hexagon, this one, through the maze until the exit. So you want to move this hexagon, moving until you can reach exit. Okay, so you have to write the instruction. For example, what is the first instruction? First, to move this, I have to move the hexagon here on this part. Am I right now? So how many units do I have to move it? It means I'm gonna move this point up to here so that I can have the hexagon here. How many units is it? 1, 2, 3, 4, 5, 6. I need to move it 6 squares to the right side. Okay, so you can write 6 squares to the right. So the first instruction is 6 squares, move 6 squares to the right, or you can write plus 6 horizontally. Okay, when you move 6 squares to the right, the hexagon will have been moved here. Okay, after that, what is the next step? Of course, we need to move it up. We need to translate it up there. How many units? How many units do we have to translate it? From this part, this point, we have to translate it here. Right, so it go 1, 2, 3, 4. 4 squares. 4 squares up. Okay, we can write 4 squares up, or plus 4 vertically. Plus 4 vertically. Okay, so it means you're moving the hexagon here and then. Okay, so next you're gonna move it here, there, and so on until you reach exit. So you keep on writing the instruction. Okay, you can choose either you want to write 6 squares to the right, or you want to write positive 6 to horizontally. You don't have to write both. You can just simply write either one. Okay, I guess. All right, that's all for the explanation of today HBL. Make sure you do it and have it submitted to your homeroom. Okay? If you have any question, feel free to ask your subject teacher. Bye.